Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course for version 7, and we were taking a look at Chapter 6 this week, and there were no labs on IPv6, although we did cover some serious ground about with SLAAC, DHCPv6, and both stateful and stateless. And so this is sort of a supplement to talk about SLAAC and DHCPv6, and I'm going to do 4 videos which are going to basically repeat the scenarios that we have here in all 4 of the labs. And so I'm going to walk through each one, and we're also going to take a deep dive look at the debug output when we talk about the stale state or the reach state or the delay state or the incomplete state. And I'm actually set up exactly as you see here on the right hand side, with the exception of my interfaces are actually fast Ethernet interfaces, and the PC is actually a Mac. So I have a MacBook Pro here, older MacBook Pro that I use for labs, and we're going to be configuring this guy for IPv6, and specifically we're going to be taking a close look at this MAC address here in terms of whether or not we're doing EUI64 or if it's being randomly generated like you see on most current Windows platforms. So again, the link local address is just FE80::1, and again, if it was router 1 and router 2, we'd do :1:2. Over here, router 4 and router 8, but we're going to take a couple looks here at some different options that we're going to see. So I'm on router 4 right now, and I just went from user exec to privilege exec. If I go into global config and then go into interface fast Ethernet 00, and I say do show IPv6 interface brief, let's make sure that we have nothing configured, right? So there's nothing configured right now. If I wanted to configure this router, or this interface I should say, on this router to have a randomly generated link local address, what would that command look like? Exactly. Well, it's going to be IPv6, and then what? Would we say address, or would I just simply say enable? Exactly. It would simply be IPv6 address enable. Now let's take a look at how Cisco does this. If I were to say do show interface FA00, here is my burned in MAC address on this router interface, fast Ethernet 00. So now when I say do show IPv6 interface brief, we see that we do have a command. In fact, let me rerun that do show int and cut it off right there. And if I roll back up here, you can see that I'm trying to get these both in the same frame. There we go. So as you can see, when I type IPv6 enable, what that command does, it doesn't give me a global unicast address. What kind of address does it give me? Exactly. It gives me a link local address. So IPv6 enable is only giving me the link local address. Now, how is this address being generated here? Well, if we look kind of toward the middle, what we'll see, and this is always something to key in on, are do you see FFFE? If we do see FFFE, what that indicates is that we are using EUI, and this is what Cisco uses by default, EUI64, in order to generate the IPv6 address, link local address, that will go onto this interface. Because remember, all I typed in was IPv6 enable. I didn't type in IPv6 address FE80:215:2BFF, etc., 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 space link local. What I typed in was IPv6 enable. And so what I'm telling the Cisco router is, I want IPv6 enabled on this interface. However, I'm not in the mood to type the whole interface in. Just go ahead, use EUI64, and you, router 4, generate that IPv6 address for me. And so here's what EUI64 format says. we take a look at the MAC address on the interface in question. Remember, the router could have many interfaces, and each of these interfaces is going to have its own globally unique MAC address, right? And so this is my MAC address. And so here is how EUI64 works. We go to the middle of the MAC address and insert FF:FE. So what does that mean for us now with the rest of the address? Well, it would be FE51:2992. There would be a, oh, sorry, it wouldn't be a colon there. And so now we've got the 2 Baker FF, right? And so then there would be a colon here. So now we've got these 4 hexadecimal characters, these 16 bits. Remember, these are hex characters. So what do we do here? Well, this is how EUI64 works. It looks at the MAC address, and it looks at the first 2 hex characters, the first byte of the MAC address. Because remember, each of these characters is 4 bits, right? So that 0 is actually 4 bits. And those 4 bits for the 0 are simply 0, 0, 0. And the same thing, 0, 0, 0, 0. So we want to look at the first byte, or the first 8 bits inside the MAC address. And what we do is we count our cell, or we count our way down to the 7th bit, going from left to right, from sort of the high order bits down to, if you think of this as one contiguous block of 8 bits, down to the low order bits. So I would say 1, 2, 3, 4, 5, 6, 7. Now, if the 7th bit is a 0, we flip this bit to a 1. And then we simply plug those values back in here, so we would end up with 0. And what is the value of this bit position here, right? And again, remember, these are 2 separate hex characters. So the value of that bit position would be 2. So we would have 0, 2, 1, 5. Right? Do you see this kind of coming together now? So here is, or here are, let me block this off a little better here. So here are the last 48 bits of my IPv6 address. And if we take a look, right, 2992, you got it, 2992. What about FE51? Yep, FE51, that checks out down here. What about 2 Baker Foxtrot? You've got it, that checks out right here. So the last 48 bits match up with what we have. So all we need to do now is prepend FE80::, and we pick up right where we left off here. So I would say 0, 2, 1, 5, : and then we would put in our 2 Baker Fox. I'm going to run off here, but that's okay. We're in red. We should be able to see it. FE, what did I say? 51:: 2992. Now, remember, we're just using EUI64, so we're going to prepend FE80::, but what's actually missing in here? How many sets of quad zeros are we missing? Well, remember that an IPv6 address, IPv6 address is 128 bits. So I've got 16, 16, 16, 16. So here's 64 bits at the end. I've got another 16 here, which brings me to 80. So how many bits am I missing? Exactly, I'm missing 48 bits. So really, if we were to write this out, not paying any attention at all to what is referred to as the rule of zeros, this whole address would be FE80::, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Because we're missing 48 bits of zeros that are located between the 2 colons. So we'd have FE80::, quad 0. Now we pick back up at 0215, 2 Baker Fox, colon FE8, I'm sorry, FE51 colon 2992. I'm sorry, it was 2992. So let me erase. Oops, let's bring that back. 2992, and this is a, sorry about that, that's a 2. So how many bits do we have? So 1, 2, 3, 4, 5, 6, 7, 8. If I were to say 8 times 16, 8 times 6 is 48, carry my 4, 128. So without using the rule of zeros, that is how EUI 64 comes up with this IPv6 address for me. All right, so if you're going to do a screenshot, go ahead and do it now. I'm going to clear the screen here. And so, again, that IPv6 enable command, all that command is doing, if I say do show run interface FA00, all this IPv6 enable command is doing is I'm asking the Cisco router, hey, please generate an IPv6 link local address for me. You'll notice that that is not generating a global unicast address. That is simply enabling a link local address. So now let's go ahead and do this. The debugs that we saw on, oops, I'm sorry, the debugs we looked at on the other screen. So we're going to say debug IPv6 ICMP, and I'm also going to say debug IPv6, not DHCP, but ND for neighbor discovery. Now we're going to get some really rich content here from these debugs that we're going to be able to take a look at in terms of the states. Now, you'll notice not really much going on, right? So I'm not sending or receiving anything, and if I were to say show run include unicast, or let's say IPv6, I've got no IPv6 ceph, and I've got IPv6 enable. Well, we know where this is at, right? This is in my global config. This is on FA00. This is in my global config. Now, if this is off, what that means is I don't have IPv6 unicast routing enabled. Because when you turn on IPv6 unicast routing, this IPv6 ceph is turned on by default, right? So as soon as I enable IPv6 unicast routing, IPv6 ceph is going to be enabled by default. Now, here's the thing. A router that does not have IPv6 unicast routing enabled, like I don't have it enabled right now, that router will not send any router advertisements or any RAs, right? So if this is not enabled, all I will send will be router solicitation messages. And this basically has me acting as if I'm a client. And so in our scenario here, we'll go ahead and say that router 4 is going to be the server, right? So, or I shouldn't say the server, but it will be sending router advertisements, and it will be providing prefix information. So I don't want to use the term server because I don't want it to be confused with when we start to talk about DHCPv6 server, whether it's stateful or stateless. So right now, the only command we have on is IPv6 enable, and we already saw what that did. It gave me a link local IPv6 address. That's all it does. Does not give me a global unicast, certainly does not give me a unique local, just a link local address. So let's, on router 4 here, let's now go ahead and kick on the router advertisements, because again, router 4 is going to be providing both the MAC that we have down here, and I'm just making sure that this doesn't time out on me. We're going to make sure that this MAC down here, as well as router 8, are going to gather up their prefix length from router 4. And router 4 will also be looked at as the default router. So let's go ahead and say IPv6 unicast routing. Now when I hit enter here, we should see a little something happen in terms of our debug output, right? And we'll go ahead and let this set itself up. So one of the first things that we want to talk about in the debug output, as you can see, as soon as I turned on IPv6 unicast routing, right? Remember, up until this point, I wasn't sending any router advertisements because these debugs were already on, right? So we already had the debugs on and nothing was happening. So as soon as I said IPv6 unicast routing or unicast-routing, what do you notice is happening? You can see sending router advertisement, and let me go ahead. I'm not going to kill the debug. I'm going to let the debug continue here. But as you can see, right, I'm now sending messages, and let's get the, where are we at? There we go. I'm now sending messages here, and we'll come down, look toward the bottom. So you can see neighbor discovery, right? The neighbor discovery protocol has a number of message types that are underneath the neighbor discovery protocol. You've got the router advertisement, you've got the router solicitation, you've got the neighbor advertisement, and you've got the neighbor solicitation. Now, we'll talk about the neighbor solicitation and advertisements here shortly, but right now we're interested in this router advertisement that's going on here. So as you can see, start up at the top, the default, so select default router, and it does it based off the rank, and the rank will be either high, low, or medium. And these are how the IPv6 hosts will determine which IPv6 node they're going to look at for as to whether or not it's going to be a default route, because there could be multiple nodes that are out there. And you can see request to send router advertisement for, and this is my address, and then set up the router advertisement, and the send was executed, and you can see by default, and we had a couple that happened really quick here. By default, the router advertisement should be every 200 seconds on Cisco. So let me clear the screen here. And oops, let me go ahead and clear the screen here, and let's hit enter a few times. We'll get some room between us and the output, because in 200 seconds, we should see that another router advertisement is going to be sent. Now, take a look at the destination here. Remember, we saw this address before. The FF02::1, and that is our IPv6 all nodes multicast, right? So this is the IPv6 all nodes multicast. Whoops, multicast. There we go. So why do you think I'm sending my router advertisement with my source address out to the IPv6 all nodes multicast? Because if anybody else is out there listening, I want to make sure that they are getting my IPv6 router information. And so think of this FF02::1 as synonymous with what we have in IPv4, which is a broadcast that goes out to everybody on that segment. And again, broadcast no longer exists in IPv6, to be clear about that. However, again, just kind of thinking of ways to remember, oh, what is this FF02::1 all IPv6 or the IPv6 all nodes multicast address? What is that all about? Well, it's just like broadcast. It's going out to everybody on the segment who can speak IPv6. Now let's take a look here. I said 200 seconds, which equals, what is that? 2 minutes, 3 minutes, and 20 seconds. So 3 minutes, which is 180 seconds, and 20 seconds, right? So by default, every 3 minutes and 20 seconds, we should get another request to send a router advertisement, and we should see that that router advertisement gets sent out to FF02::1. Because now that I've configured IPv6 unicast routing, I want to do SLAAC, right? Because again, if I didn't want this to be providing the prefix information, if I wanted him to be a client and only wanted him to send router solicitation messages, I would have never enabled, there would have been no reason to enable IPv6 unicast routing, at least in the use case here. Again, this is separate from a conversation of, if we're running routing protocols. But we're just talking this IPv6 conversation. So if I only need him to be a client and he just needs to get some IPv6 information, his global unicast information. All he needs to send is a router solicitation, because the router solicitation says, hey, is there anybody out there who can help me out? I need to get the I'm looking for some IPv6 prefix information, global prefix information, so that I can get a global unicast address. And that's what the solicitation is. Again, he's soliciting other routers on the segment who may be providing that information. And those routers that are providing that information are sending router advertisements. So routers that are sending the router advertisements are the ones that are saying, hey, here is my information. And they're firing it out again to this all IPv6, or the IP, I keep saying this backwards, the IPv6 all nodes multicast address. So did we make it? We were at 906.38. And was this, and whoops, it shifted on me. Let's clear the screen. So it sent its last advertisement here. I just shifted again, but that's okay. So we had 2106.38. And we ended up at 2109.44. So just 3 minutes. And what's the difference here? Not much of a difference. It was 6 seconds. So close to 3 minutes and 20 seconds, right? But this is, I'm sorry, yeah, 3 minutes and 20 seconds. It was close. So that is your 200 seconds ballpark that Cisco will automatically send out a router advertisement, right? So the question is, what if a node comes up onto the network and the advertisement isn't being sent? Well, that's what that router solicitation is for, because that's where a new IPv6 node who is asking for that prefix information, he'll send a router solicitation out. And so let's go ahead now and let's take a look. We're going to go ahead and set this guy up to provide the information that other clients will be interested in. And I can't remember what I said here. So yeah, we're just going to use 2001 DB8 Cafe 1::1, because again, I need to provide the global unicast prefix. So let's jump into interface fast Ethernet 00, and I'm going to go ahead and say IPv6 address. And the address is going to be, what did I say, 2001 DB8 Cafe 1:1/64. Now, we're going to see some more activity here in our debugs, and this is going to be good because now we're going to get to see the neighbor solicitation message going out along with a neighbor advertisement, which is all part of the duplicate address detection. So now on this interface, remember, do show run interface FA00. What do we have? So I now have the IPv6 enable command here, which, let me ask you this. At this point, do I need the IPv6 enable? Because remember, every interface must have a link local address, right? Okay, and there we go. And I'm going to go ahead and let me say, whoops, clear the screen here. Let me say do you all. So we're going to stop the debugs here for a second. We'll roll back to the output that we're interested in, which we just saw. Okay, so do we have to have this IPv6 enable at this point? Whoops, at this point. And the answer is no, we don't need that now. Because as soon as I configure an IPv6 address, a global unicast address, this interface will automatically generate via EUI64. It'll automatically generate for me a link local address. Remember, we used the IPv6 enable before we had the global unicast address. Now that I have the global unicast address, what do you think is going to happen when I say, let's click back in here, when I say no IPv6 enable? Anything happening with my debugs? No? No updates, no changes, nothing. What if I say do show IPv6 interface brief? There you go. So I still have the same link local address. And this link local address, if I were to clear the config on this router and reload this router, and it came up with nothing on here, and I went right back into that interface, and I said IPv6 enable, we would end up with the exact same link local address. In fact, if I were to say do show int, and actually the interface is not plugged in, so let's see, this may or may not work. So I'm going to take a look at the burned in MAC address here on FA01. And just looking at that, we can predict what that link local address would be when I use IPv6 enable. So we know it starts with FE80 colon and then 1234 colon 1234 colon 1234. So these are my first 64 bits, right, of my link local address. And again, we're talking about FA01 here. So real quickly, it's very easy for us to figure out what would happen, because we know that FFFE is going to go right here in the middle, and the 7th bit is going to flip, right? So we've got 4 bits here and 4 bits here. The 7th bit here, which if your Mac begins with 00, it's pretty easy to figure that out, right? Because it's always going to flip that 7th bit, and if it's 00, you know that it will always end up being 0215 colon. Now remember, we've got the 2 baker, so 2 baker FF colon FE51 colon 2993. So if I were to shrink this all down, I would have FE80 colon colon, and again that wipes out these guys here, right? They're gone. So and then we start here 215 colon 2 baker Fox colon FE51 colon 2993. So place your bets. Let's jump into FA01. I'm going to type IPv6 enable, and this is going to be a tough one here. So I'm going to leave that up on the screen instead of trying to clear it and rewrite it. So let's say Control C, and I'm going to go into interface FA01, and let's say IPv6 enable. Let me make sure we no shut the interface, although there's nothing plugged in right now, and so that's got me concerned as to whether or not this is going to cooperate. So, and you can see there the interface has gone down. So if I say do show IPv6 interface brief, let's take a look. So it generated the link local address. Even though it's not plugged in, it generated that link local address for me. And what do you think? Pretty close? All right, I'd say we're spot on. FE80 colon 215 colon 2 baker Fox. And so this is EUI 64 again, right? Same thing, EUI 64. So let's clear the screen. And let's roll back here now. So now I've created, and I've stopped the debugs. So now I've created a global unicast address. And the first 64 bits here, this 2001 DB8 Cafe :1, that is my global unicast prefix. Now, when we start to bring other routers, or I should say this other router here, it's going to be router 8, when we start to bring them online, we're going to set them up so that they're using SLAAC, right? And so we'll talk about SLAAC here in a second. So again, quick review, that FF02 colon 1, that is the IPv6 all nodes multicast address. That's where my router advertisements are getting sent, as you saw, right? And when we talk about the router solicitations, it'll go to the all routers multicast address, the all routers multicast address, not the all nodes multicast address. And there's a difference, and we'll see what that difference is here in a second. So let me go ahead and say debug IPv6. What did I say? ICMP, and we're going to say debug IPv6 neighbor discovery, right? So let's slide up here. So let's make our way over here to whoops, and it has locked me out. And this was, I'm trying to remember my password here. There we go. All right. So you can see that we still have some of the same information here. Now, what about Macs? How does a Mac generate its link local address? Well, these are your key identifiers right here. If I see FF:FE in the middle, there is a very good possibility, right, more than good, that this is EUI64. And again, the Ethernet starts with 00, so right after the FE80::, we know that the first character is going to be a 2, followed by 1 Baker, 63, Fox, Fox Echo, Alpha Delta. So again, Macs use EUI64. Now, the last Windows OS that used EUI64 that I'm aware of, and it may be Vista, but was Windows XP. And I know that for a fact. I used to use XP a lot to generate a lot of IPv6 config type things, and would see that the link local would always be FE80 with the FFFE in the middle. So that was the last version that we used. In class, you know, we're on Windows 7, and are we using, yeah, Windows 7, and so the Windows 7 is not using EUI64. It's randomly generating that link local address. All right, so now that we've got ourselves set up and we've put our prefix information out there, if I were to say if config-a, am I picking up an IPv6 address? Right, so remember, this is the Mac, and he's got IPv6 set up. He's ready to go. Take a look here. You've got it. So 2001 DB8 Cafe 1 :21 Baker. So we've got two different addresses here that are IPv6 addresses. So what if I were to say ping 2001 :DB8 Cafe :1 :1, and is it ping 6? I'm trying to remember here. Give me a second. Yeah, there we go. Ping 6. Sorry about that. Whoa, and then take a look there. So take a look there, and we're going to come back to this. So these are the debugs, Deborah, that Deborah saw. We'll come back and take a look at this, and this, let me put an end to that right now. So again, we're debugging. We've got a lot of information here, kind of got a little bit ahead of ourselves, but wanted to show you that we have connectivity to and from those global unicast addresses. All right, so now let's move over to Router 8. We're going to bring Router 8 into the fold now. And remember, Router 8, there's no configuration here. So show IPv6 interface brief. As you can see, no IPv6 information configured at all. So here's what we're going to do. We still have our debugs running over here. And there's that reachability and stale state information. If I were to say show, real quickly, a little ahead of ourselves, but show IPv6 neighbor, what do you think that information is? You've got it. So that's the information from the IPv6 neighbors that I know about. And the state is stale. However, the information is still kept in the neighbor cache. And just thinking ahead a little bit, when you see this, right, it went from probe to reachability, okay, and so it became reachable, and that was right around 21, 24, 12, and at 21, 24, 42, and 32, and this one's tied into the FE80 address, right? You see the FE80 address here, so we come down to the FE80 address, and that is almost exactly 30 seconds later. Now, there's a reason for this, so we'll come back to it. But again, we've got some, again, rich output here. Definitely want to take a look at this output while we've got it up in front of us. So let's clear the screen. We're going to go back over here to Router 8. And on Router 8, we're going to set up the, actually, we'll set up the same debugs. Debug IPv6 ICMP. And we're going to say debug IPv6. I always forget, neighbor discovery. Neighbor discovery. All right. So we're debugging. We've already confirmed that we've got no IPv6 information. And so all I'm going to say here is IPv6 enable. And remember, what is that going to configure for me? It's only going to configure, randomly generate, and let's actually take a quick look. So do show interface FA00 because we're on a different router now, a different set of addresses, but we know what? Look at that. You got to love it when it starts with 00 because you know immediately it's 02. So it's going to be FE80 colon, because remember we've got 48 bits of zeros in here. And then it's going to be colon, we're going to drop the first 0, 226, colon, 0 Baker FF, colon, FE, 3 Delta, colon, 5298. All right, that's where I'm placing my money. I'm putting my money on that being IPv6 enable, on that being the link local address we end up with. Now, what about global unicast? And we'll see that here in a second. All right. So as you can see, we had the duplicate address detection. And let me bring this back here. So you can see here we had DAD request for FE80 colon 1 on null 0. And it says FE80 colon 1 is unique. FE80 colon 1 on null 0 up. But let's take a look at the FA00 interface. Do show IPv6 interface brief. And what is the actual link local address that was randomly generated for us using EUI64? It was FE80 colon 226. Yep. 0 Baker Fox. Yep. FE3 Delta. Yes. 5298. Right? So EUI64 is really very straightforward. And so there's our address. Now you'll notice that I'm not receiving or sending. You don't see any, we don't see any what here, right? We don't see any router advertisements, and we don't see any router solicitations. So the first question, why don't we see router advertisements? You've got it. If I say do show run include unicast, which would be, what am I looking for? I'm looking for that IPv6 unicast routing command. If that command is not there, remember, I am not going to be sending any router advertisements. And like I'd mentioned earlier, this is outside the scope of routing protocols. But in the real world, the chances are, if this is a router, and I wanted to get its global prefix, right? Global unicast prefix from another router via SLAAC, which is plausible. And I wanted to run OSPF v3 or EIGRP v6. How could I do that? Because I have to have the IPv6 unicast routing command on. So here's how we do that. So on the interface, I'm going to go ahead and say IPv6, neighbor discovery, or I'm sorry, no IPv6, neighbor discovery, and I am going to, I thought I had it there, where's suppress? There should be a, oh, and it might not be here. Now this is interesting because this is a 15, it's not actually 12.425 code that's running here. This is 15.1 code, and I'm wondering if it's smart enough to figure out no IPv6 nd suppress RA. So there's a command, and I'm wondering if it's smart enough to know that I don't have IPv6 unicast routing enabled right now, although it should have let me set that. Let's see if 15.3 code has it. If I go into interface FA00, the command I'm looking for is IPv6, or actually it's no IPv6 neighbor discovery followed by suppress RA. Or is it RA? Ah, it's RA suppress. Okay. So our text showed the command no IPv6 neighbor discovery suppress -RA, right? And what that means is that I can turn IPv6 unicast routing on. However, I'm going to suppress router advertisements. So we should have that. So let's say no IPv6, neighbor discovery, router advertisement, suppress. So this should suppress router advertisements. And I'm going to turn IPv6 unicast routing on now. So this is how you would say, and if I moved over to the picture here, so this is how you would set something up like this. If I've got a router here, let's say I got another router here, another router here, but this is the only router because let's say that this guy is the default gateway out to the internet or whatever the next segment is. He's my default gateway out, so only he is going to be doling out the global unicast prefixes to these guys, router 5, router 6, we'll say router 7. And I don't want any of these guys out here, 4 or 5, let's see, what is this, 8, 5, 6, 7, and 8. I don't want them sending router advertisements. There's no need because it's all going to be taken care of by this gentleman right here. So this is how you would do that. We would suppress the router advertisements from being sent on the interface in question, right? In our case, it's fast Ethernet 00 here on router 8. And then, because I want to do EIGR IPv6 or I want to run a routing protocol, I go into interface fast Ethernet 0. I'm sorry. I go into global config and I say IPv6 unicast routing. Now, we're going to fact check this because we've got all these debugs on, and we should see whether or not he decides to generate, or did I not turn debugs on? I apologize if I didn't turn debugs on. So debug IPv6 ICMP, and then debug IPv6 neighbor discovery. So we've turned IPv6 unicast routing on, and in fact, let me do this. I'm going to turn it, no IPv6 unicast routing. I'm going to turn it off. I want to make sure that we see something here out of these debugs. And then let's turn it back on. And I'm hoping to see, and is this guy not doing the debug? Well, we can double check. Let me see. So I should say logging console. Yeah, logging console. So let's turn it off. No IPv6 unicast routing. I can check it on the other side, but I'd like to see it here. And we're not. Do show log. Is it even logging? It's not logging anything. All right, let me come over here. Sent router advertisement. We did not see a router. Did I? Let me double check that interface. FA00 do show run interface. I have it shut down, don't I? I do not have it shut down. So interface FA00 and IPv6 enable is on. So again, we're not sending any router advertisement. We're not doing anything like that yet because I've got IPv6 unicast routing on. However, now the question is, there's one command that I'm missing here. What is the command that's required in order for me to auto-magically acquire or start asking other people for the global unicast prefix? And that's a command that we've covered before, where we're going to go ahead and say IPv6 address auto config. So I say IPv6 address auto config. I'm going to hit enter here, and let's say do show IPv6 interface brief. Let me make sure, and it's showing up down. So it's showing up down. So that's my problem. Let me pause. Let me check the switch this is plugged into real quick to make sure, because we clearly have a layer 2 issue here. And I'm wondering if I need a crossover cable. Because again, this isn't... Well, no, it should not be the case. Give me a second here. Let me double check on the plugs to make sure these are the right routers are plugged into the right ports. All right, well, that was definitely interesting. I'd actually plugged the cable in to another 2811 that I have that's not even on the screen here. So I got the cables rerouted here, and we're picking up literally where I plug the cable in. So you can see right here, Fast Ethernet 00 changed its state to up. So then what happens right away? We have an ICMP-v6 neighbor discovery. And did not want it to roll past like that. Let me go ahead and get that back up here. So we had the ICMP v6 neighbor discovery. There we go. On Fast Ethernet 00, I'll try to work through this quick. So we had a duplicate address detection request for what? That FE80, right? Now, here's the key. Neighbor solicitation message. Now, these are used to get your layer 2 information. So I send a request out. This is router 8. Sends a request out to : : that is the unspecified IPv6 address. Because I don't have an address yet. Because I'm doing duplicate address detection. So I send it out with my source as nothing because it hasn't been confirmed that I can use this address, or not this address, sorry, this link local address. Remember, IPv6 duplicate address detection is going to check every time the interface comes up or down to make sure that the address is not in use. And what is the destination? And this is interesting. It sends it out to the multicast address using part of my MAC address. So it basically sends it out to who would be me, right? And this is how duplicate address detection works. The source is nobody because, again, I haven't been confirmed as being able to say with 100% certainty that this link local is not being used. So what do? I fire out a multicast based off of my MAC address to see who responds back. Because if somebody were to respond back to me, then what's going to end up happening? Exactly. We've got a duplicate address situation. If nobody responds back, then I can go ahead and say with certainty, hey, I can use that address. And again, we had the same thing happen when we sent out, take a look right here, duplicate address detection. Because there is my global unicast prefix that I am learning auto-magically along with what? You've got it. The rest of the global unicast address is those last 64 bits are EUI64, right? It's auto-magically generated for me. And it gets sent out, and I learn that it is unique. And that's what duplicate address detection is all about. Now, nowhere in here do we see what kind of an advertisement. If I scroll back up, and we're on router 8, so you can see that we have a router solicitation going out. Let's make sure we're suppressing router advertisements. And it looks like we created an RA and we're sending an RA. However, that was when our link came up. We are not providing any prefix information. So we'll keep coming down. And so you can see here, and actually it's interesting, it is showing sending and receiving even though we're suppressing. And I'm not, again, the command that I've seen and that we've seen in the text is suppress dash RA, and this was RA space suppress. So we are receiving, right? We're clearly receiving router advertisements. And again, another request to send a router advertisement. And so there goes that router advertisement again. I'm wondering if this is not the command, or if I'm not running a recent enough version of code to merit that. So over here on R4, now let's go ahead and say, show IPv6 neighbors. And you can see the neighbors that I have. So we already know that this is what? And they've been in here for 20 and 19 minutes respectively. So who is this? The feed, or FEAD. Well, let's pull this guy back up here. And this is my MacBook Pro, and I'll say if config. And there's a reason that we don't see router 8 yet. So I say if config -A. We go up to interface 0, and you've got it. That is the link local, right? FEAD. That is the IPv6 address, my link local address right here. And here are the global unicast addresses, right? And that one right there is the FEAD. So as you can see, we've got 2001 DB8 Cafe 1, 21 Baker 63, and there it is, EUI 64 with the Fox, Fox, Fox Echo. So I have an entry for the Mac in here, show IPv6 neighbor, and this is the neighbor cache. Now the state is stale, and that's okay because I still have an entry here. So what if I were to say ping, and let's ping that global unicast address. And we are still debugging, so we should see some activity here. And this is what we're looking for, and this was Deborah's question. And I'll kind of let this run a little bit here. And we're going to wait 30 seconds. We'll give it a 30-second break, and we should see a message that says reach. It's going to come up and say reach with an arrow to stale. All right, boy, right on cue there, huh? Beautiful. So, what does reach mean? Reach means when it goes into the reach state, the neighbor, it's been validated that I have reachability to that neighbor on that address. When it goes to the stale state, which it will do in 30 seconds if there's no additional traffic. So once the ping stopped, I'm not sending any additional traffic right now. So 30 seconds later, by default, it will move to the stale state. Now, the stale state is not necessarily a bad thing, and let me show you why. If we roll back up here where I kicked off that ping again, you can see echo request sent, source address, destination address. And it's just like ARP for IPv4. And I had a feeling that was going to happen. It's just like ARP for IPv4. Is when I go from stale to delay, right? That's a new one here, delay. What does delay mean? Delay means is that I am resolving the layer 3 to layer 2 information, which means I'm confirming that whoever the host is that I'm trying to ping here, which is this MacBook Pro, that the stale information in the neighbor table is still legitimate. And the information specifically is the MAC address that I have in there for this host. Again, it's just like the ARP table for IPv4. So when I say ping 192.168.1.1, if I don't have a MAC address, right, cached off, I have to fire out an ARP saying, hey, I'm trying to find 192.168.1.1. What is your layer 2 MAC address? Because I need to forward traffic to you. And it's the same thing here with IPv6, except we're using ICMPv6 neighbor discovery messages, right? When we're trying to dig up that layer 2 information, that's the neighbor discovery and the neighbor solicitation. And then you can see right here it moves from delay to reach when it makes the confirmation, when it gets the confirmation that yes, that information in the neighbor table is legit. So let's go back, and you can see here we're still sending those neighbor advertisements. Say show IPv6 neighbor, and there you go. It's stale information, and that's okay. And we're still going to use it, but we're going to validate that before we move from the stale state to the delay state back to the reachability state. So again, if I rerun that ping real quick, let's catch it. We'll let this fly by here really fast. We're going to have 30 seconds. Now if I say show IPv6 neighbors, what is the state of that information? Exactly, you've got it. The state is reachable, right? It's reachable. Now, the question here is, and we'll wrap this up because again, we're talking about SLAAC, and SLAAC is very straightforward. We're actually done. We've configured SLAAC. So when I come over here to router 8 and I say do show IPv6 interface brief, did I get the 2001 DB8 Cafe 1 prefix here? Auto-magically done, right? First 64 bits are my prefix length, my global unicast prefix length. My last 64 bits, again, EUI64, giving me those bits by using the MAC address on this specific interface. And you can see these router advertisements. Every 200 seconds, we're getting the router advertisements. So, back over here on router 4, you'll notice we don't see anything from router 8. Why is router 8 not in the neighbor table or the neighbor cache? Well, the reason is exactly why we didn't see the MacBook Pro in there either. It's because we haven't generated any traffic. So let's go ahead and do this. I'm going to say do ping, and we're going to ping the link local address of the router from which we're receiving this router advertisement message. Now, it's probably going to ask me output interface. Yep. So I'm going to say fast Ethernet 00, and let's see what happens here. And there you go. And we're definitely going to roll back, and this is great, right? We see we've got incomplete. The code incomplete came up as well. So again, really getting a deep dive look at the conversation taking place between these two routers. So I kick my ping off, right? It was 100%, and that happens. And that happened pretty quick. I want to move back up here. And in fact, here, I'm going to kick the debugs off here because we are do you all. And there you can see 30 seconds went by, and we went from reach to stale, right? So we'll scroll back up here because this is really the output that I'm interested in. When we take a look up here, you can see the echo request got sent. My source, right? This is my link local address, so that is my source. The destination, this is router 4. So what happens here is we get this delete moves to incomplete because we have no entry in our neighbor cache for the destination that we are trying to get to. So if it's not there, right, it says it's deleted and we move to incomplete. And what incomplete means is I'm trying to get the layer 2 information, but it's incomplete right now. I don't have it. I've got this layer 3 address here. Well, I've got a layer 3 address, but I don't have the layer 2 information. So how do I get that? I'm going to send a neighbor solicitation for FE80 215 2 Baker Fox FE80 2992. We know that this guy, that's router 4. So then I resolve the next hop to router 4. I send the neighbor solicitation. I receive in return, after I solicit, right? My neighbor solicitation says, hey, FE80, and this is me, right? The source. And I fire it out to the FF02::1. And the neighbor solicitation is saying, hey, I'm trying to get to router 4 via that link local address. What is your MAC address? And then I get the neighbor advertisement back from whom? You've got it. The neighbor advertisement. So who responded to me after I fired it out to the all IP, or the I always say that backwards. The IPv6 all nodes multicast address. I fire it out saying, hey, I need to get over to router 4. Here's the link local address I've got. Router 4, if you're out there, give me back your layer 2 MAC address. So I send that out to the IPv6 all nodes multicast address, and I get a neighbor advertisement back from, received from who? Router 4, and he says, because here's his address right here, right? There's router 4's link local right there. And the destination comes back directly to me at my link local address. And at that point, it's no longer incomplete information that I have in my neighbor table. Because again, at this point, I have now done the resolution from the layer 3 address to the layer 2 address, and I've established reachability over to router 4, right? All right, so let's clear the screen here. And the last thing that we're going to do, and I know this seems like for SLAAC we've gone on forever, but a lot of details to cover here that we need to talk about. So the last thing we're going to say is if I say do show IPv6 neighbors, I only see router 4. But who does router 4 see? Show IPv6 neighbors. And sorry, I got mixed up in there. So show IPv6 neighbors. Now I see router 8, and I see my MacBook. Right? I see my MacBook Pro, and I see router 8. But which address do I see for router 8? I only see the link local address, because which address did we ping? We pinged the link local address. So let me clear the screen here. And as one last final thing here, if I say show run interface FA00, I'm going to grab the IP address here. We're going to come over to router 8, and I'm simply going to say do ping. So there we go. We've got 100% reachability. I come over here. You can take a look. We've got sent neighbor solicitations, received a neighbor advertisement. Again, went from probe to reaching, and then again stale to delay, delay to probe, and then probe to reach. Right, so great output right in here. So before it goes stale, let me say show IPv6 neighbor, and now we have the IPv6 neighbor cache entry. So again, SLAAC is up and it's working beautifully. 30 seconds have gone by. We go from reachable state to the stale state. Because again, 30 seconds of no traffic, IPv6 iOS will transition it to the stale state. We keep the entry, and we will use that entry, right? We'll still use that entry when we go to do the resolution. However, we're going to validate that it is legitimate before we use it. Okay, so that is SLAAC in a nutshell. Again, to recap, IPv6 unicast routing, you're going to send RA messages. However, you can suppress those. To enable just the link local address with EUI64 on the Cisco routers, you simply type in IPv6 enable. Once you type in IPv6 auto config, right? And did we actually type that in here? Do show run interface FA00. Yeah. So once you type in IPv6 address auto config, you no longer need that IPv6 enable. And the use case here is you've got flexibility. Hey, if you don't want global unicast addresses, or you don't need global unicast addresses, then you don't need to put that IPv6 address auto config on here. You can simply type in IPv6 enable, and it'll automatically generate it for you. However, you're probably going to be better off typing in IPv6 address FE80::8 link local. And watch what happens here. Now that we've changed the link local, right, we've got all kinds of advertisements going back out, neighbor advertisements going back out, router advertisements going back out. So again, we just changed the address, and that is why. And you can see here, right, this is, again, fantastic output. There is the prefix length that I am giving out to neighbors that are sending me router solicitation messages, or RS messages, who are requesting prefix information from me. Okay, so we're going to go ahead and stop here. The next scenario that we're going to take a look at is stateless DHCP v6, and we're going to continue to drill down with IPv6. All right, I appreciate you guys watching. I hope that this has really solidified your understanding of what happens with IPv6 when we go to enable it on router interfaces, how we can do it what are some of the options, the use cases, right? With that IPv6 enable, IPv6 address auto config, and the IPv6 unicast routing. We've got SLAAC up and running. And we validated that on both the router and our Mac. All right, I'll see you in the next video.